Whose life would be better if you knew more C++? Whose life would be better if your coworkers knew more C++? Let's get started.
All right, so welcome everyone. Welcome to the Back to Basics track, and welcome to this particular Back to Basics talk, the special member functions. Allow me 10 seconds to introduce myself. My name is Klaus Iglberger, and I'm perfectly okay if we stick to the first name because, as I've realized, many Americans are not able to pronounce my last name anyway. So I'm Klaus, and I'm working as a C++ trainer/consultant. Today, I want to talk about the special member functions. And this is the functions that a compiler might generate for you. So let's remind ourselves what these functions are. So which functions does the compiler generate within a class? Well, of course, it's the default constructor, it's the copy constructor, the copy assignment operator, the move constructor, the move assignment operator, and last but not least, the destructor. These 6 functions are, depending on the situation, that's exactly what we'll explain, generated by the compiler, and that is the so-called special member functions, because they are indeed special. First of all, because they are generated by the compiler, and second, of course, they are very basic fundamental functionality of a class. Copy functionality, move functionality, cleanup, and of course, default initialization. So right away, in order to just explain the terminology already, if you hear people talking about something called rule of 6, then they're actually talking about these 6 special member functions. Basically, they say all of these functions are somewhere defined. If you hear people talk about the rule of 5, however, then this means that they talk about these functions, all of them except for the default constructor. That one, okay, is not so special after all. It's probably the most boring out of these 6. These 5, the remaining 5, are probably the most important. Then sometimes, still, you might hear people talk about the rule of 3. Traditionally, people mean that you have somehow defined the 2 copy operations and the destructor. It's not quite up to date anymore, but still might be relevant. And sometimes, and hopefully more than sometimes, hopefully most often, people talk about the rule of 0, which means that the class does not have any explicit definition of any of these 6 special member functions. And already at this point, this is good. This is kind of the best that you can have. This is your goal. So we set this goal for ourselves, but of course I have to explain why this is a goal, why this is something that I want to achieve. So let's talk about these 6 special member functions in order. I'll start with the default constructor, then I'll make a jump, talk about the destructor, then I'll talk about the 2 copy operations, and then about the 2 move operations. All right, and so let's start with the default constructor, which could be indeed a pretty boring story, because just explaining when the compiler generates this is actually not a lot of information. The compiler generates a default constructor if you have no other constructor in your class. So, for instance, this widget, that widget does have a default constructor. I can create this widget either in this form or in that form. Parents, unfortunately not possible. That's a so-called vexing parse. However, if you have any constructor in your class, any other constructor, then the compiler doesn't generate the default constructor for you anymore. And that may be totally reasonable. Sometimes, hopefully only sometimes, it might not make sense to have a default constructor. And by defining or just declaring any other constructor, this default constructor is disabled. That's nice. Good to know. But a default usually is quite a good thing to have. But also, the compiler is not able to generate any default constructor if any of your data members or any of your base classes cannot be default constructed itself. So for instance, if I do have any data member that does not have a default constructor, then the compiler cannot just do anything. It doesn't know how to default construct a widget. So it will throw up the hands in the air and say, I have no plan what you want to do. And then again, you don't have a default constructor. which is kind of reasonable, I believe. Now, as I said, it would be a little boring if this would be all the information, but we can perhaps talk a little bit about the initialization, the task that a default constructor is supposed to do. And let's start with this widget. This widget has an integer, which now for me is a representative of a fundamental type. Could also be a float or a double. I do have a string s, which now for me is a representative of a class type, a so-called user-defined type. And I have another special fundamental type. I have a pointer to an int. Now, in the main function, I create a widget in this form. I use default initialization. Think about this for a second. What is the initial value of these three data members? What is the initial value of I, of S, and of PI? Now, I assume you have an answer pretty quickly, or a gut feeling. So, the integer is not initialized. The string, on the other hand, is initialized properly to an empty string, but also the pointer remains uninitialized. That's definitely something that you want to avoid. That's definitely something that will later haunt you, because a random address, anything is pretty difficult to distinguish from a real address. So, no, the pointer definitely not. The pointer should not be uninitialized. So, if you don't have any default constructor, then all data members of class type or user-defined type are properly initialized. That's good, based on their own initialization routines. But data members of fundamental type are not initialized. Now, instead of default initialization, allow me to use the so-called value initialization. I just use an empty set of braces. This luckily fundamentally changes the behavior. Because this class doesn't have any declared default constructor, this now means that the integer is properly initialized to 0. The string is, as before, initialized to an empty string, but also the pointer suddenly is null pointer. And that, of course, is absolutely superb. Absolutely amazing. This is what we'd like to have. So in that particular case, value initialization has the added bonus that, because of any missing default constructor, we are first zero initializing the entire object before we then afterwards construct all the class types. So the string will then afterwards be initialized by its own default constructor, which doesn't really change anything. But the zero initialization, first of all, takes int of the I and the pointer. Very good indeed. Absolutely great. So if you do that, as just explained, first the object is zero initialized, then all the non-trivial data members are default initialized. Good. However, if you now start to, guideline first, prefer to create default objects by means of an empty set of braces. So value initialization is actually a good thing in general. However, if you now start to write a default constructor yourself, and then, by means in this form, you just have an empty default constructor, then even this syntax will not save you anymore. Again, the integer is uninitialized, the string is still default initialized, but the pointer again is uninitialized. If you write a default constructor yourself, if you define it in the class, then you are responsible. And this one is just not doing anything. So, if you write an empty default constructor, again, all the data members of class type, the user-defined types, are initialized, but not the data members of fundamental type. So, in other words, if you write this, you have to do something yourself. Definitely better than an empty set of braces is to ask for the default. To ask the compiler, please generate this for me, because then, good thing, everything is working out again. So the int is initialized, the pointer is initialized, and the string anyway. Equal default counts as a definition. which is at this point not a problem at all. There may be other situations, but this equal default actually may also give you a couple of bonus effects. For instance, no except. That's something that you might not have thought about before, but equal default actually is something where the compiler now starts to think about all the details, and you might, for instance, in this situation, since C+17, get the no except for free. Pretty good indeed. So please avoid writing an empty default constructor. And I mean the one with an empty set of braces. Prefer to let the compiler provide a definition or define it by equal default. Now that's definitely a step forward. But of course, it could be that you want to initialize the object to a specific state. So let's assume that we need the value 42 for the integer. What else? That we need CppCon for the string. Again, what else? And I don't have a particularly clever value for the pointer. Let's say we use null pointer. That now definitely sets the value to all of the desired values. Okay. However, the comment is lying a little bit. Actually, this is not initialization. That is assignment. I'm assigning 42. I'm assigning CppCon. I'm assigning the pointer. An assignment means that I'm changing an existing object. Initialization, from a terminology point of view, however, always means that I'm calling a constructor. So if assignment changes an object, uses an assignment operator, then where are the elements initialized, where the constructor is called? Well, before you enter the body of the constructor. Before you enter the body, there's something called the member initializer list. And this is where you should put all of your initialization. So the string should not be initialized, should not be assigned in the body. Now it should be properly initialized in the member initializer list. And yes, for the int and the pointer, it doesn't really make a big difference, but still, in C++ we consider to be very good style indeed, to initialize as much as possible in this member initializer list. So the int, the string, and the pointer are now initialized to the values I desire, and it's clean. That is good. This is exactly how the code should look like. So a very simple, straightforward default constructor, an empty body, which is great because this basically means that I initialize things and I do not waste time by first initializing to something and then changing it later. So please remember the responsibilities of the default constructor. Everything, in most cases at least, should be properly initialized. Then also note that I actually filled the member initializer list in exactly the same order as I had the member in the list of declaration. So I go back one slide. I did initialize the integer first, then the string, then the pointer, because that is exactly the order that I have them down here. That's not optional. That's actually a binding order. You have to initialize these data members in exactly that order in the member initializer list, which is good. There's a good reason for that, which is unfortunately going a little bit beyond what I want to talk about. And then also prefer initialization to assignment and constructors. That is what core guideline C49 tells us. It is definitely good style. It is considered to be very valuable. All right, the default constructor. Let's switch gears. Let's talk a little bit about the second special member function, the destructor. Every class has a destructor. That's something that hopefully is clear already. Every class has a destructor. Either you write it or the compiler will generate one for you. So this class has a destructor because the compiler generates one. And if you declare or define a destructor, then of course the compiler will not generate one anymore because you have now provided one. Okay, so that's the simple part. However, of course, destructors are there for a reason. Compilers are supposed to clean up an object. When the lifetime ends, all outstanding responsibilities should be taken care of. Now the default, the compiler generated destructor, calls a destructor of all data members of class type. Now, so if I have a string, that destructor is definitely called. But the compiler-generated destructor does not call anything for any fundamental type. So strictly speaking, there is no destructor for these kinds of types. No, not for ints, not for pointers. But now in my example, I actually do have a pointer. And this pointer is, of course, now for me a representative of a possible resource. Perhaps it doesn't own. Then everything's fine. But perhaps it does own. And if it does own, the compiler-generated version, the compiler-generated destructor doesn't help me at all. The compiler-generated version would not clean up the pointer, would not clean up whatever's behind that pointer. So in that case, you have to create this, write this destructor yourself. You would have to delete the pointer explicitly. Okay, typo, without the tilde. That is important, of course, else you have a resource leak. However, I believe this is something that people do quite well. And destructors very often are not a problem. Usually destructors, however, are a sign that you have to deal with other functions. And that's the ones that we are now talking about. The copy operations and the move operations. So please just remember, provide a manual destructor if there are any outstanding responsibilities that are not handled by the destructor of a class type data member. So if you do have any owning pointers, then you do have to write one yourself. And do not provide an empty destructor. That's a bad habit. If the destructor doesn't do anything, let the compiler generate it for you or define it by means of equal default. But just as an empty default constructor, an empty destructor is kind of strange. All right, I see a question by J. Castell. What happens to classes that have only static members of not fundamental types? A static member is not truly part of an instance, so a destructor is not concerned about your static types. Static data members, so in other words, the ones where you add static before that, basically live for the duration of the program, not for the duration of a single instance. So once again, the destructor is not concerned about them at all. The destructor would not clean this up. Now, it depends on the type. If you have, you said not fundamental types like strings, they're created at the beginning of the program, they're destroyed at the end of the program. All right. So let's talk about the copy constructor and the copy assignment operator, the copy operations. First, the signature. The copy operation, the copy constructor, is thus the constructor that takes one argument of the type of the class. The first signature here, that is the default. That is kind of the canonical form. This is what you should use in 99% of all cases. You could also, if you wanted to, remove the const. This would still be the copy constructor. However, I personally would vote this as suspicious. I've seen one class in the standard library that had that auto pointer, which now is history. Apparently it wasn't a good idea. So leave it in const is indeed suspicious. And then technically, you could also pass by value, which however is not a good idea at all. This may result, if you pass an L value into a recursive function call, and so we can forget about this basically right away. So you either pass by reference to const or by reference. The copy assignment operator is pretty similar. The copy assignment operator is the assignment operator that takes one argument of class type. By default, by reference to const. Again, this is what you want to do in 99% of all cases. Sometimes, but again, I would rate this as suspicious, you might do it this way, or you might remove the const. This is still the copy assignment operator. Or, and actually here it might make sense, you might actually pass by value. By this, doing that, you can actually implement copy assignment in terms of copy construction and move construction, depending on what you have. But this actually might sometimes be a nice compromise. It might reduce code a little bit. So here it's possible. All right, let's talk about when these operations are generated. The compiler will always generate the copy operations. if not some points apply. But if you do have a widget against some class and you don't do anything special, then this widget does have the two copy operations. Definitely. The compiler will always try to make sure that there is a working copy operation. The only reasons why there's no copy operation is if you write them, okay, then they're still there, of course, but the compiler will not generate them anymore. All right, so your version will be used. Then if you have a move operation, then the compiler will actually implicitly delete the copy operations. They're not gone at all. They're implicitly deleted, which essentially means if you try to copy, you will get a compilation error. Copy operation has been implicitly deleted. So again, there's always a copy operation. It just might not be available. And also, if you have any base class or data member that cannot be copied, then the compiler just cannot generate the copy operations for you. Also in that case, however, they're not gone, they're implicitly deleted. If you try to copy, you will get the according error message that explains why it is not copyable. So, every class has the copy operations, essentially. Every class has a copy constructor and a copy assignment operator. Either you can copy by means of these, or they are implicitly, or if you want to explicitly deleted. But every class always under all circumstances has the copy operations. Pretty important to keep in mind indeed. You cannot get rid of them. You cannot delete them. You cannot replace them with something. These two functions are something that we'll always have to deal with somehow. All right, let's talk a little bit about the... Oh, I'm sorry, there is a question which I should address. So the guideline says to prefer an empty constructor. However, that relies on the user of your class to use the braces to zero initialize the data members. Isn't that a concern? Well, what you can, of course, also use is in-class member initializers. If you want to make absolutely certain that your class is properly initialized, especially the pointer, then you have to do something yourself. You should not rely on the user to do the right thing. You should write your class such that it's definitely initializing everything to the values that you need. So just saying that it is a good habit to actually use braces. This is not a wrong thing. Absolutely not. But you as a designer of the class should not rely on the user to do something. That would be a problem. I agree. All right. How are the copy operations still there if they're implicitly deleted? All right. Equal delete actually is not a get rid of it. Please read equal delete more as equal disable. Now you're asking the compiler to disable it. Equal delete counts as a definition. So you do define the function, and if it's defined, it's there. And essentially, and I hope indeed this clarifies it, it's always part of the overload set. If you try to create an object, then the compiler will always, so if it takes a look at all the constructors, it will always consider also the copy constructor. It's always there. If you say equal delete, it just cannot be called anymore. It can be selected in the overload set, and then later you get the error message, oh, it actually has been deleted. So, to some extent, equal delete is a misnomer. It's not gone, it's not deleted, removed, whatever. It's disabled. And also implicitly deleting means it's just disabled. Okay, Alan has a great question, I believe, but a pretty long one. I'll try to tackle this later. Okay. So let's talk about the default implementation. What does the compiler do when it generates the copy operations? The copy constructor is basically done this way. So you may have a base, so some colon base, imagine that. Bases are just initialized directly in the member initializer list. And then the compiler does a member-wise copy. So I is copied, S is copied, the pointer is copied. The compiler generates a default implementation of this copy constructor by doing a member-wise copy. And exactly the same is also happening in the copy assignment operator. The compiler would just generate one that does a member-wise copy. If you do have a base, several bases, it would start with these. It would copy the base part, then it would copy the int, it would copy the string, it would copy the pointer. That's it. It's a very, very basic forward way to generate this copy operation, which is great if you have ints and strings. But it might, it depends, not be such a great idea if you do have pointer data members. So again, I assume I have a pointer, which now for me again is representative of some resource, an owning resource, something that I have to clean up. Now, we talked about this before. I said that in that case, you should write a destructor. So let's write a destructor. However, obviously, the default implementation that the compiler provides is not working perfectly. If you just copy the pointer member-wise, then actually we duplicate this pointer. If you have two widgets and I copy the widget, now there's two widgets out there that hold the same pointer. Both of these widgets naively would expect that they own this resource, and both in their own destructor would call delete. Very bad idea. That, of course, is something that we definitely should avoid. This kind of shallow copy is of course, a problem. So, in order to fix that problem, I now create a real copy. Of course, there is many options. Now, in my example, I create a real copy. So, if the other has a real pointer, I create a copy of the other resource, and else I set it to null. And here as well, I do not just copy the pointer, I create a new resource by new, assuming that this is the right thing to do. As I said, there's many possibilities. New resource might not work, of course, in every situation. Still, we're not done yet, unfortunately, because in this line, we are now changing our pointer in the assignment operator. And as I've said before, the assignment operator is actually critical. The assignment operator changes an existing object, changes the ownership. And I might already own something, some old resource that actually, I'm responsible for. This is why I wrote a destructor. For that reason, I definitely should do something about my old resource. So it's my responsibility. I first of all have to delete my old resource. Okay, type again, delete PR. I should delete my own old resource. Now it's okay. Now I've dealt with my, my old resource, and now I can take another one. Or, if need be, I just get a null pointer. Okay. Still, it's suspicious. I would rate this as very suspicious indeed. We call it cleanup, we call it delete outside the destructor. And indeed, this now can result in a lot of problems. For instance, a special case that can happen in case of assignment, if we assign to ourselves. So if you have some widget W, and I say W equal W, that is what we refer to as self-assignment. In that case, this reference, this other, would be myself, me. If that happens, then the first thing I do is I delete my old resource, my own resource. I continue, and at this point I actually find that, well, it's still the old pointer. I try to copy it, but of course I try to copy from something that doesn't exist anymore. That's a classic bug. It's classic forgetting that self-assignment is a real thing. It can happen. All right, so you do realize that because we write this function ourselves, because we manage this resource, suddenly we have to deal with many, many, many more details. It's amazing how many details are suddenly coming upon us. In this function, we suddenly have to deal with delete and with new. We also have to deal with, of course, copying all the base classes and data members, but we also have to deal with null pointers and potentially dangling pointers. Yeah, my own pointer here, my PR, is a dangling pointer right here. Oh, how could this little function become so complicated in such a short time? And indeed, it can happen quickly. And you hopefully do realize that all of these problems are just coming because of the pointer data member. The pointer is to blame. If I would just have an int and a string, everything would be fine, but the pointer suddenly messes this up completely. Not a good idea. You should, of course, always strive for code that is simple, code that is reliable, code that you can look on and actually say, it's working, it's correct, I know that it is. And I've not even talked about exception safety here, so there's indeed a lot to think about. It is not easy to write such a function yourself. There's always something complicated, but there is an easy way. One approach that is kind of easy. And that is what we call the temporary swap idiom. The temporary swap idiom works the following way. You create a copy first, a copy of other. This other is copied into temp. And of course, this calls the copy constructor. A function that was actually much, much more straightforward. A function where we did not have to think about possible delete, null pointers, and dangling pointers. It was definitely simpler. So we trust that function. We use it. Now we have a copy, temp, but, well, that's not the right position of this copied thing. Actually, I want to be the copy of other, not temp. So directly afterwards, I now swap the state. I swap the state of other and myself. I'll show the swap function in 2-3 slides, don't worry. So I swap the entire state. And that's actually pretty beautiful because it does the right thing and we actually build on existing functions that we already know, functions that we already trust, namely the copy constructor and of course also the destructor. The destructor will now destroy temp at the end of the scope. So temp will be destroyed exactly at that point. And will clean up my old resource. Yes, I don't have to take care about this anymore manually. I can leave it to the destructor of temp. And indeed, that's kind of beautiful. By the way, this solution is safe for self-assignment. That solution is also exception safe, even strongly exception safe, which I now leave aside too deep. And it's short. But now, of course, there's critics in the audience that will complain that this is not the fastest possible solution. Yes, absolutely. But it's simple. And if you do not have any specific performance requirements, if you just want to get it done, if you need it, that's actually one very nice way to go. But of course, if you want to do the right thing, if you want to be fast, then of course you could write this function yourself. For instance, special case, if both widgets, both other and myself, have a valid pointer. So if both pointers are valid, then, typo, I could actually copy everything explicitly. I could copy the base classes, I could copy my data members, and not just I don't copy the pointer, I actually copy the resources themselves. So I do reference the pointers and I copy the resources by means of their own copy assignment operator. So I can make this truly a very hierarchical thing. I implement my own copy assignment by means of all the other copy assignment operators. And the nice thing is that, again, I don't really have to handle self-assignment in this case. The data members will do this on their own. That's perfectly fine. If, however, one of these two pointers is not valid, and of course I assume that this is possible, then in the else branch I could handle this by means of the temporary swap idiom. That may be a better way of doing things, a faster way, but again, one that of course makes this not as nice anymore. It's definitely a little bigger. The swap function. Of course, the swap function that you should write is now a member function. A member function that actually takes a non-const reference to another widget, and a function that first allows the compiler to actually also use standard swap, and then simply swaps all the data members. The ID, the name, the resource, and potentially also base classes, whatever you might have. That's the right kind of swap implementation. I do not explicitly and qualified use std swap, std : swap, but I first ask the compiler to consider std swap, to also consider it, and then I do an unqualified call. That enables ADL, the argument-dependent lookup, to actually pick up the right swap for special data members of some other namespaces. So that's what core guideline C83 tells you. For value-like types, consider providing a no-except swap function. All right, now that's nice. But now we have all of these special member functions. We have the copy constructor, we have the copy assignment operator, we do have the destructor. And that is exactly what people refer to as the rule of three. If you define any of these three, and for us it was the destructor that we wrote first, then it is very reasonable to actually think about all three. Simply because, well, they're all connected. If I have a special implementation, my destructor, it definitely will affect, I say definitely, most likely will affect the copy assignment operator. So they are indeed connected. So if you write one of these three, please consider all three. Do not leave some aside. And indeed, this is what I see often, too often, unfortunately, that copy operations are just ignored. That's very unfortunate. Now, sure, again, there's critics that say that this rule of three is outdated since C++11 because there's two more, the move operations. Okay, I give you that. Most of the time, probably it's not the one thing anymore. Consider the rule of 5 in a bit. But there is actually still a use case, which I'll cover at the end. So a good reason why I would use the rule of 3. All right. However, all of the problems indeed are because of the raw pointer. It's probably reasonable to actually use some data member that knows how to clean up things automatically, like a unique pointer. Raw pointers are usually trouble indeed. Owning raw pointers, which shouldn't exist to the core guidelines, but we now replace this by a unique pointer. That means that automatically we do not have to think about cleanup anymore. And that means that the destructor can now disappear. We do not have to think about a destruct anymore. Unfortunately, we still have to think about the copy operations. We do have to because a unique pointer cannot be copied. So the default generated version that a compiler would generate, the one that would try to copy, just doesn't work because now this is one of the data members that cannot be copied. Now, of course, you could think of another data member, like a shared pointer. A shared pointer can be copied, and it also, of course, deals with resources. But before we now move on, please do realize that this absolutely fundamentally changes the semantics of the class. Before, I was actually talking about a widget where each widget owns a resource. Now we're suddenly talking about a lot of widgets that share one resource, shared ownership. That is indeed something very, very different semantically. So that is not a general solution. That may be a special case if you indeed want to have shared ownership. So let's assume for a second that this is what you want. And you probably should think about this again, because shared ownership is troublesome sometimes, or often even. But assuming that we decided to use a shared pointer, then we actually can also get rid of the two copy operations. A shared pointer can be copied. It can be cleaned up. Everything suddenly is automatically generated. The compiler version works perfectly. And suddenly this is so much easier. Suddenly we don't have to think about any of these copy operations, the destructor anymore. Much easier. And this is exactly what we refer to as the rule of zero. Classes that don't require an explicit destructor, copy constructor, or copy summary operator are so much easier to handle. And that's why you want to go there. This is why you should strive for that, to make your lives easier, to have a good evening, to not have to worry about any bug in the implementation. All right, so let me check if there's any questions. Okay, Thomas asks, when the copy constructor applies a member-wise copy, types with const members can't be copied. So a simple answer about that, you should try to avoid const member data. Initially, it sounds like a good thing because const is great. Actually, it may be the most valuable keyword in the language, but const data members are not. Because exactly, they mess with the copy operations. They also mess with move, because obviously you could not move from a const member. Please, that is something that you should avoid. Const members and reference members are troublesome. The copy assignment operator and also move assignment and even the move constructor are affected by that. The compiler cannot generate these anymore, the assignment versions, assignment operators. That's not a good thing. Definitely not. There is a core guideline that says exactly that, avoid const members and reference members. I just remember the number correctly. Might be 82, but this is a wild guess. Okay, I hope this answers the question. Jesper asks, what is a scenario where you would do self-assignment? Okay, let's just say that it could happen. I don't say that you want to do self-assignment. I say it is an operation that should work. You should actually implement an assignment operator such that it also can deal with self-assignment somehow. Not for the case where you do it explicitly. No, that will not occur. Never, I believe. I've not seen it. But for the case where it just happens. Imagine an implementation of some algorithm. As a special case, indeed, an object might be copied to itself. A swap that swaps the same thing. It may happen. Your code must be prepared for that. That's the entire reason. Self-assignment is important to take care of. All right, and Ellen asks, what about using weak pointer? Okay, weak pointer is, of course, a very special thing. Let's don't go there. Shared ownership, as I said, is something that you want to avoid anyway, because it's hard to reason about. Unique pointer is usually much more your friend. That's what you should use primarily, say 90% of the time. All right, so let's talk about the move operations. And I know, as soon as I say, let's talk about move, half of the people sign off immediately. Oh no, move. Okay, I know this is always a big topic. It always sounds very complicated, but here's a little incentive to actually motivate you to go through move. Oh, very nice indeed. Very cute. And note that I actually take great care to actually include everyone. So dog fans and cat fans alike are now very happy. I just have to apologize. That's something I didn't really think about before. I actually indeed did forget about people that have a cat hair or a dog hair allergy. I'm sorry about that, but okay. You now should feel motivated to go through the move stuff. So the signature of the two move operations. The move constructor takes usually a reference, an R-value reference to non-const. That's the default in 99% of all cases. Technically, you are allowed to add a const. It's possible, but uncommon. I've seen it in production code reasonably. If you don't really want to move, if you just want to see that any R-value reference is passed, then this may make sense, but it's very uncommon indeed. And the move assignment operator is absolutely similar. Yeah, the assignment operator that takes one argument of class type by 99% reference to non-const, R-value reference to non-const, and you can add a const, but again, very uncommon special cases. But all of these count as move operations. Now, when does the compiler generate move for you? Well, if you have nothing inside your class, especially no special member, then the compiler will generate move. So that widget, pretty much empty, has no move operations. But if you write them, declare or define them, then of course the compiler will generate these two. Then, if you do write any destructor or any copy operation, then the compiler would actually not generate move anymore. It would be gone completely. It's not implicitly deleted as the copy operation, but move indeed would be gone. So that destructor or any copy operation would actually make move disappear. And of course, your data members and base classes has something to do with that. It's a little more difficult though, as with the copy operations. If your data members or bases can be moved but not copied, of course, then you still can move. That's perfectly okay. The compiler knows what it should generate. It can call move. If your data member cannot be moved but copied, still the compiler knows how to generate the move operation. Your data member, or also base class, would just be copied instead of moved. Okay, it's not perfect, but that's the best we can do. Still, move kind of works. But only if your bases or data members are truly immobile, in the sense of they have neither the move or the copy operations. So, in other words, indeed, there's no way to get it anywhere else, then the compiler does not generate the move operations anymore. And again, they're not implicitly deleted, they're gone. There is no move. They don't participate in the overload set. Now, the default operation. How does the compiler generate the move operations for you? Well, the move constructor does a member-wise move. So the base part would be moved, the data member I, the data member S, the pointer, they would all be moved. A member-wise move of all the data members. The move assignment operator does exactly the same thing, kind of. It's just doing not move constructions, but move assignments. So the base part would be moved into the other base part, I would be moved, the string would be moved, the pointer would be moved. So a member-wise move of all the data members. That's what move is doing. And again, this is perfectly fine if you have just things like ints, strings, and other data members. But again, I do have a pointer. Because of that pointer, again, I write delete resource in my destructor explicitly. And you can imagine that this, of course, again has an impact. In the move constructor, we're lucky we don't have to do anything. But in the move assignment operator, again, first of all, for both functions, we have a shallow copy again. A shallow copy that, again, will cause trouble later. If you move a widget, there's two widgets, perhaps then eventually even more widgets that believe they own this resource. They will all call delete. It doesn't work. Because moving a pointer essentially copies the pointer. So again, we have to do something explicitly. And please again note, it's the pointer. The pointer makes your life harder. So I now clean this up by, in a move constructor, exchanging things. And in a move assignment operator by first deleting my old resource explicitly and then exchanging. Sounds so simple. But again, very, very suspicious. I do have a delete outside the destructor. And if you do have an explicit delete, then please check if all the operations are actually doing the right thing. That exchange here is indeed suspicious. It is suspicious for the special case. Move to self. So move assignment by self-assigned by means of move. So you have some widget W. You could say W is equal to std move W. Yes. And if you do move to yourself, then you first delete your own resource. Exchange would make sure that you keep the pointer, and you would end up with a dangling pointer. Very, very problematic. So yes, a delete pretty much always is suspicious. You have to think harder about the code. You have to take care of the special cases. It's always a little more trouble. Therefore, either we do things explicitly, we first assign a pointer, then set the other pointer to null pointer. That works. It's a different order than Exchange would provide. That is something we could do. Or alternatively, we could also use, again, the temporary swap idiom. This time, however, by moving other. We now rely on the move constructor and then swap. Now, it's the same swap as before. That works. And yes, again, it's not the fastest implementation. The faster one is the one that I just showed to you, the version before. But that is the version where you do not have this suspicious delete. That is the one that makes us feel a little more safe, a little more secure that we actually have done the right thing. That's good. All right, now we're kind of again at the rule of 3. This time, however, we have the 2 move operations, destructor and 2 moves. But now from experience, you remember that of course in that situation we also should deal with copy constructor and copy assignment operator. They're not gone, they're still there. As I said, every class has the 2 copy operations. So now in total, actually we deal with 5 functions. And that's what we refer to as the rule of 5. So if you do have to write a destructor for some reason, then most likely you will also require the 2 copy operations and the 2 move operations. Suddenly you have to think about all of them. And of course, that kind of sounds like work. So again, the raw pointer causes all this trouble. The pointer that we have to take care about explicitly, manually. What we should do is again to think about how to deal with this in a better way. And the first thing I would now again propose is to move to a unique pointer. A unique pointer takes care of deleting things. That means we can actually get rid of the destructor. But a unique pointer also perfectly implements the move operations. So I can move a unique pointer. Very nice indeed. So I can get rid of the 2 move operations and the destructor. I just cannot get rid of the copy operations if I need them, if I really want to have copy. So unfortunately, we cannot go to the rule of 0 right here. Again, if you would assume that a shared pointer would work, and again note that of course it again fundamentally changes the semantics of the class, so this is not an equivalent implementation now. If you would have a shared pointer, then we could also get rid of the 2 copy operations. Then again we would arrive at the rule of 0. So again, this is what we should strive for, but not at the expense of changing the semantics of a class. That's not okay. Semantics first, and then you have to see what is the proper implementation. But I hope this is a point that you now got on your own. Seriously important from my point of view. Try to reduce the use of pointers. They make your life so much more difficult. And here, this is the core guideline. R21, prefer unique pointer over shared pointer unless you truly need shared ownership. And trust me, you don't need that often. And it's not an excuse to have a simple implementation. It's a different semantics. All right, to summarize the guidelines. Okay, let me check. Okay, Alexandre asks, isn't widget now the signature of the move constructor, but with a const? So is widget in parens widget const ref, isn't that really a copy constructor? No, it isn't. It isn't because, of course, the move constructor accepts R values, only R values. The copy constructor, the const widget ref, would accept both L and R. So in a special case where you actually don't have any data members but still have something special about move, and I say, indeed, I have seen this once or twice at maximum in my lifetime so far. That was code where indeed it was only about detecting R values. It was not about moving. Then this actually makes sense to have the const, but it's not the copy operation. L values would not bind to the R value reference to const. So it cannot replace the copy operation, not completely. Okay, I hope this answers that. Michael asks, why does move assignment operator return a widget ref instead of a widget ref? Okay, this I didn't explain. I apologize. Returning a widget ref is the canonical return statement of any assignment operator. Always. You always return a reference to yourself. So you yourself, of course, usually are an L value, but it's something that it indeed is a canonical return statement. This is what all assignment operators do, not just the copy and move assignment operator. You actually may change the return type. That's perfectly okay. But then I've seen static code analysis tools that complain that you do not obey to the convention. So stick to this convention. It's the right thing to do. You always return reference to an L value reference to yourself. Okay. So let me address the other questions in a little bit, just to make sure that we actually cover these guidelines. So once again, core guideline C20, that is the rule of zero. That is the thing that you should strive for. So this class here, this widget that has a pointer and a size, apparently allocates an array, makes its life harder than it should be. You should consider, not always of course, but most of the time consider manual resource handling as suspicious, as difficult, and you should leave that to some classes that already do that. So that widget could also be implemented in terms of a vector. That's so much simpler, and that would definitely achieve the rule of zero. C21 also says, that's the one that says rule of 5. If you define or delete any default operation, define or delete them all. Now in this class, in this widget, I have a unique pointer, which is good because that definitely takes care of delete. So I don't need a destructor. But we've seen before that we need the copy operations. So now we can copy a widget. But now you have to remember all of these rules, these intricate rules, this rule set which operation influences the other operation. Well, because of these copy operations, we have no move anymore. If you write copy, there is no move. So we would now get back the move operations. We can simply default them. That's all we need to do. Please compile it, generate them for us. That's good. However, in order to show that all of them are working properly, we now also default the destructor. We do that in order to avoid any questions, in order to just show we've thought about this, it's okay. And it's super simple and super quick to do because we can use equal default. That is the rule of 5. So if you write any one of these 5, please write all of them. That makes your life simple, and it definitely does not require anyone to remember this artificial rule set of rules. It's not bad rules, it's great, but complicated. All right, so note that equal default indeed defines all of these special member functions. Yeah, it's a user-defined, user-specified operation. Of course, you're also free to delete the copy operations. explicitly. You can say, no, I don't want to delete, but please make it visible. Then everybody has an idea of what you have in mind. So if you have a unique pointer and if you say, no, copy is not for me, delete the copy operations and default the others, no questions from anyone. Okay, and I've said that sometimes the rule of 3 may actually still make sense. Sometimes, indeed, like in this class, I might have no move operations. That actually has a special meaning, because now if you try to move, we are actually falling back to copy. So this object is not movable, but it is copyable. But if you now delete the move operations, if you try to move, you will get a compilation error. And so, interestingly, it indeed does make a difference whether you do not write them or if you delete them. There is a difference. Equal delete says it is there, but it cannot be called. And so, as a final takeaway, follow the rule of 5 if you want to default or delete the move operations. But if you want to have copy as a fallback, if you don't need move, but you want everything to be handled by copy, then you might still follow the rule of 3. Then you just do not mention, not delete and default the move operations. I would add a comment though. It's kind of a nice thing for people that read your code. They now understand what you have in mind, but from a functional point of view, you follow the rule of 3. Okay, and the last guidelines, please be suspicious of manual resource cleanup. That is the reason why we talked about all of these details. The pointer, the cleanup, that is what made all of this difficult. And try to reduce the use of pointers. All right, thank you very much. I'm over time by 1 minute. I apologize, but I will answer all remaining questions in GatherTown. So please give me a minute, then I've logged in, and then I can answer all your questions as long as you need me. Okay, thank you again.